We did. It was a big pay cut. We had to beg our technical crew here. We want to thank Kareem, who's here watching us. He allowed us to grace the stage of the Cisco U Theater here at Cisco Live Melbourne, and it's been a great event. Have you enjoyed your time?
I have. Ran some labs, some breakouts, some Cisco U Theater sessions. The vibe has been fantastic. People are happy to see us, happy to talk about their certifications, talk about learning, and come and take exams as well, right? We have a testing center, so loads of people are taking exams. So that's been the highlight for me.
It has been, and relevant for all of us here at CCNA Prep. There has been a ton of interest in taking the CCNA here at the event. I'll admit, I went and actually retook the CCNA this week to get a feel for how the exam's going. We've heard that there's been some kind of interest in what's going on with the lab. We've added some new lablets, some of the structures in there, and it was exciting to sit back down and get prepped for season 3, because I'm gonna give you a peek behind the curtain. When I took the exam, we saw a lot of topics that are relevant to what we're going to talk about today and the rest in season 3. Security is a big topic in the exam.
So if you remember, season 1 was just back to basics, right? We looked at stuff about VLANs and trunks and OSPF, really the fundamentals of networking. And then season 2 was all those cool services that we can deploy in a network, so DHCP and NAT and all of that. And then season 3 is all about security, and we're kicking it off with our favorite security theme, maybe, layer 2 security. So we're going to be looking at port security. We're going to be looking at DHCP snooping and dynamic ARP inspection. And the doors have just opened here at Cisco Live, so people are starting to trickle in and joining us in our live studio audience, which is very different from when we do these live from home instead, right?
Yeah, normally the closest I have to a studio audience is my dog Oreo. And he doesn't give me all the energy because he generally just sleeps through the sessions. Like all day long, he just sleeps on my floor. I keep trying to get him to come through. He hasn't registered for a CCNA exam yet. What do we think we can do? Are we allowed to register canines?
Can you, as a pet or just as a support animal, maybe?
Oh, yeah, maybe that would work out.
I'm noticing that some people are also trickling into the Slido, letting us know where they're from. Clearly, a few people are from the United States of America. That's great. I don't see anyone yet from Canada. I think it's what we said, 10 Pacific, so 1 p.m.
It just hit 6 o'clock back home.
So, okay, there we go.
Eastern,
right?
All right. So we're getting in there. Though as the folks come here, I do feel like we should be able to get live from Melbourne, Australia, higher up in the Slido poll if you all join in and kind of vote it up on that side.
Yeah, so as you're sitting in, please join the Slido. We're going to have a few polls coming up throughout the session. So this is a 1-hour session. It's really geared around the CCNA exam. And as we said a few minutes ago, the focus today is all about layer 2 security. And if you haven't registered for the CCNA prep program, please do so. You have access to all of the previous episodes that we've done. They're available on demand. And that includes the YAML file for CML, so you can spin this up yourself. PDFs with multiple choice questions to kind of test your knowledge. What else do we usually include?
Oh man, so every one of our CCNA prep series, if this is the first time you come to one, includes a hands-on lab. We don't do a ton of slides in our CCNA prep. We go through demonstrations. We show how these technologies work. We dive into them inside of CML. And so you'll get that CML file and then a detailed lab guide that will allow you to kind of redo these exercises. We generally target to try to make these labs available in CML free, the free edition. But if you don't have access to that, we also provide packet tracer files. And so you can do these labs inside a packet tracer. The goal for CCNA prep really is in the name, is to prepare you to kind of go and sit and take and pass your CCNA exam and earn that certification.
And like Hank was saying, there's been quite a substantial change to the CCNA exam over the last year. We've started adding what we call actual labs, right? Some people call them lablets. We call them performance-based assessments or skill-based assessments. So when you sit to take the exam, you're going to have 2, 3, 4 of these little mini labs where you have to deploy something. You have to configure something. It could be a VLAN. It could be some trunking. It could be OSPF. But it could also be layer 2 security. And that's why we're here today, to look at that in particular. This is looking good. Got about 30 people so far signing in.
Fantastic.
The live from Melbourne is getting bigger, which is nice.
It is, but
still disappointing here about the Canadian.
Sorry, not Canada. That's pretty good.
Oh, there's a Canada. All right.
Oh, somebody's over there. All right. Well, we're getting there. Okay. All right. Is it time to dive in, Patrick?
I think we can get going.
All right. We're going to dive in. We're going to dive into the actual topic. As Patrick mentioned, today is all about layer 2 security. One of the first things I ever wrote a blog post about, believe it or not, about 12 years ago, was layer 2 security. And I always like going back to some of that fundamentals, because we talk about it in the CCNA, But what's strange is so many people kind of bypass that as they're deploying and designing and architecting networks, which makes me kind of smile and wonder a little bit, why do we overlook some of the most basic aspects? And so maybe we can convince each and every one of you to go back and turn on port security and consider DHCP snooping when you get back next week into your offices.
And I think to mention also, we're just scratching the surface. And what I mean by that, let me just pull up the CML. So this is the CML lab that we're going to be using this morning for this demonstration, right? This lab that we're going to do together. But the thing I did is I went to the CCNA exam topics themselves, right? You can download those on the Cisco Learning Network website. And I pulled the line that really kind of drove us wanting to create this session today. And it's right here. So it's domain 5, item 7, configure and verify layer 2 security features. And what's nice is that we're specifying exactly which ones you should be learning and understanding and being able to configure, which is a high order level of expectation, and verifying as well. And that's exactly what we're going to do. We're going to configure different flavors of port security and DHCP snooping and dynamic ARP inspection. But not just stop with the config, we're going to verify. Is it actually working? Is it doing anything? And can we verify that in the lab environment as well? The point I was just trying to make very, very quickly is that we're literally just scratching the surface. There's so many other layer 2 security features that we can deploy. I think we talked about a couple of them when we did the spanning tree session in season 1. So BPDU guard and stuff like that. So there's loads of other little features like this that we can definitely talk about.
All right. Well, let's dive into it. Let's get into our first feature. Where are we going to start out?
Can we get Rigo to drive to the next poll question? It's all done. So if you're looking at the poll question, we're kind of going to give away maybe the answer a little bit already here. But the first thing we need to talk about when we talk about port security are, let me just move this up a little bit so we can have a look at it together, are these two pieces of information here. So the first one we need to talk about and understand is what are the different types of secure MAC addresses, because we're going to focus initially with port security, right? That's our topic in part 1 here. What are the different types of secure MAC addresses that I can configure with port security? And there's 3 of them. I have a favorite. Do you have a favorite of these 3?
Absolutely. I mean, I'm a big fan of sweets, cookies, cakes, anything that's sticky. And so that's going to be my favorite, mostly because I'm a little bit lazy and having to keep track of the manual MAC address changes in my entire network is just a ridiculous fashion that's out there. Now, before we even dive into that, why is securing MAC addresses considered a layer 2 security feature? Like why would somebody even want to do this? What's the purpose of doing anything related to kind of MAC address security in my network?
Yeah, I guess my thinking around that is that I want to lock down the devices that are connected to specific ports on my access switches. And so that's fundamentally my layer 2 connection right at the access layer within my network. I want to be able to pick up that layer 2 MAC address from the device and say, okay, that one belongs to this port and this one belongs to that port. And I guess the point we're getting at is there's a few different ways that you can determine how those MAC addresses will belong to these different ports.
It is.
And that's what you were getting at here.
And the key idea here is you might be, what's it matter? Like nobody's going to be able to plug into my switch port other than me. Well, the fact of the matter is in a lot of our networks and organizations, that's not the case. One of my first jobs as a network engineer was at a hospital, and we had network Ethernet ports in hallways where phones might be connected, where printers were connected. And anybody could just walk into that location, unplug the printer, plug their laptop in. And without a feature like this, where we noticed that MAC address changes and said, hey, there's a problem here, don't let it go through. Now anybody has just jumped onto whatever network that printer was attached to. Really is a critical thing that we have to keep track of.
And so there's 3 different ways that you can lock this information down. The first one is probably the one that Hank was getting at. It's the one that requires a lot of effort and a lot of work, and it's the static one. And that means you've got well-documented MAC information of your devices. And this can be really useful when you know for sure that this device is always there and you own it. So maybe it's a server, maybe it's a really, really specific device. And so you can go to that port and say, this is the MAC, and that's the connected there, and that's all. So there's a couple of other options. The next one is the dynamic one here. That's the one where it's going to look at the MAC address table on the switch, right, where it's learned that MAC address from the device that's been plugged in on a port, and then kind of keep that one as the secure MAC address. But the problem with that one is that if someone disconnects, switch goes down, the port goes down, someone connects something back in, it might just learn this other new MAC address and just keep going. So this is good, but I think Why do you like
sticky.
that one the most sticky? Yeah.
Well, it gives us the balance of both of them. I don't have to manually keep track of a database of all the MAC addresses of every phone and PC and printer that's out there,
Yeah.
because a lot of organizations, printers might come and go as they're swapped out. So what Sticky will do is it will go through and use the dynamic nature. So when something gets connected to that port, it dynamically learns it, and then it stamps that in the configuration to say, okay, this is now the one that's going to be on this port. And so if the switch reboots, as Patrick mentioned, it won't allow the next person to plug in and take advantage of that. It's locked in. Now it's stuck there until you actually release it as the network administrator, because there may be a point where you say, okay, this printer died, or the network adapter in this this server, this desktop PC has gone bad, and we swapped it out. MAC address changes, so we can very quickly go through and say, okay, let's release that and allow the new IP address to be saved and stuck into the configuration.
Maybe we can ask a question to people in the chat who are joining us online, and for you guys that are here this morning. When I wrote here stored, and I ask you all, stored where on the switch? Which one, sorry? Definitely, I'll pick it up in the MAC address table, but Hank was saying we're gonna actually save that MAC address. Is it stored in running config or startup config?
We're getting a call out over here.
Yeah. NVRAM? Yeah. Not quite right away. Initially, it'll be in the running config. And so like Hank was saying, if I've learned these MAC addresses in a sticky fashion, they're now in my running config. If I turn off the switch and turn it back on, I'll have lost them, right? So, right, the tip or the best practice is that once you know that you've used sticky and you've picked up all the correct MAC addresses where they should be, and they're now in your running config, what's the thing to do? Yeah, WR, if you're old school, or copy run start if you're a little younger, maybe. No, I'm just kidding. Yeah, you want to lock down those addresses as much as possible, for sure.
Fantastic. All right, well, let's get into it, Patrick. I think it's time to show some configuration.
Yeah. So what I've decided to do for this lab, as you can see, the topologies over here. I'll just show you very quickly. Really simple topology. I've got 3 PCs. I've put them all in the same VLAN. I've got an access switch, a distribution switch, and I'm using the external connector so that we can ping out to the internet, just for some quick testing, basically. And so right now, the DHCP server that I'm using is actually based on the CML server. So I don't have a DHCP server in here. I'm using the DHCP server that's built into the CML server. So if I pull up, for example, I can do a quick ping from this PC out to the internet. You can see that that works fine down here. I can also do a quick release renew of my IP address. You can see that I'm picking up an IP address from the DHCP server as well. And I haven't deployed any security yet. We're about to do that in a second, but just before we do that, I think we need to talk a little bit about this first, right? So there's 3 types of port security violations. You're gonna get exam questions for this, for sure, if you're taking the CCNA exam. 3 different types: protect, restrict, and shut down. Need to make sure you understand the difference between all 3. Let me run through them very quickly, and then we'll go deploy them. Protect is an interesting one. It will block the traffic. It will drop traffic from a MAC address that is violating the policy, but the switch won't let you know. It's gonna do it quietly, and I'll show you how quietly it is. It's extremely quiet. You won't know that anything really is happening, except that the PC won't be working correctly anymore. Very subtle. But sometimes you want a little bit of information that something has happened in your network. This is where restrict and shutdown come into play, because these 2, not only will they drop the offending traffic, they're going to send a syslog message, and we'll see that in just a sec. It's going to send an SNMP trap as well, and it will increment a counter showing you that something has happened, right? A security incident has occurred, and we're going to increment that counter. Shutdown goes beyond what restrict does, because restrict will keep the port up. And this is kind of interesting. So if I have a port that has multiple devices connected to it, maybe there's one that's offending, but the others are good, they still need access to the network. I still want to block the one that shouldn't be accessing my network. But this is the most aggressive one. What does that one do?
And it's an important thing to keep in mind, because when you're in a shutdown port, it will error disable that port, and it will stay down even for valid traffic until the administrator goes through, understands what went wrong, and explicitly un-error disables or re-enables the port that's on that side. And so these are very specific, and there are use cases, I think really good use cases for both restrict and shutdown. If it's a super critical port and you want to know, and if a bad MAC address shows up, may indicate some other level of compromise, right? You want to shut that down so you know what's going on. But if the risk for that is just a case, well, it might show up, somebody plugs into a bad hub someplace, or a daisy chain switch that's out there, we'll just restrict, we'll prevent those unknown machines. Yeah. The one that I cannot for the life of me in my entire time as a network administrator figure out a good use for is that first one, protect, right? Why would you just drop it and not want to know? Because that's just going to generate help desk tickets, right? You're going to spend hours trying to figure out what's wrong because you've got no symptom, no logs, no counters, no anything on that. So my advice is just avoid protect completely. Stick with restrict for most of them. And if it's a really critical port, that's where shutdown is super valuable.
So the topology I was showing you is extremely basic. It's just layer 2. I'm not doing any routing. The PCs are going through that access switch, through a trunk to the distribution switch, and then out to the internet and getting their IP address. So I just did a quick ping just to refresh everything. The PCs are connecting and able to ping to 8888. And I just pulled up the MAC address table because we were talking about that a few seconds ago. And I want to point out the MAC addresses that I've configured on these 3 PCs just to make it easy for us to kind of figure out which one's which. So 11111 is PC 1, 2222 is 2, 3333 is 3. They're connected to ports 1, 2, and 3, right? So I try to keep it as simple and straightforward as possible. The other MAC addresses are getting picked up off the trunk going to the distribution switch. So you can ignore those ones. We'll just focus on these ones. So what I thought I would do on this lab with you this morning is I wanted to come up with some kind of interesting combinations of the different types of secure MACs and violations. So what I've got, you can see them, I wrote them down over here, 1, 2, 3. So for PC1, we're going to configure that one for a static MAC address, and we're going to use protect. I just want to show you how quiet it is when there is a violation. The second one will be restrict and dynamic. And then the third one will be the shutdown sticky, which is the one that when I was teaching NetACAD, we use that one a lot in lab environments to kind of demonstrate what's going on. So any questions so far? Are we good? How's everything in the chat? Great. All right, so let's have a go. Can you guys see this okay? Is that all right? I know it's a little difficult maybe for those of you that are behind me here. So I'm going to go to gig. Actually, you know what? Just a second. Before we do that, let me just do a show port security. Show port security interface gig 01, right? There is no port security configured right now, but I just want to show you what the default values are before we start turning on some stuff. So you can see port security is disabled right now. It's not on any of the ports. It says secure down because, well, there's nothing happening in terms of port security. And this is where things get interesting. And this is where you might get an exam question, right? What is the default violation type for port security on a Cisco switch? Well, there's the answer. It's shutdown.
Yeah, we default generally to the most secure types of choices that are in place. So.
There's no aging type, and I'll talk about that in just a second. Here's another default value. You could get an exam question there too. What's the default maximum number of MAC addresses that are configured for port security? 1. Right. So those are just, I just want to show that information. This is where our violation counter is going to be and the MAC address of that violating address as well. All right, so here we go. Conf T. Int gig 01. What did I say? We're going to do static and we're going to do protect here. So the one thing that I recommend to my students when we're configuring port security is do all of the parameters first and then turn on port security. A student would ask me, do I really have to do that? And I'd have to be honest, you don't have to. You could turn on port security and then do all the parameters, but it's probably not going to work really, really well. You might have to do a no shut on the interface just to kind of reset everything. So
well, keep in mind too what you'll run into if you do that. If you turn on port security and you're going after the initial default feature or secure mode is shutdown. And so if you do your order of operations weird, you may end up actually getting your port error disabled and then not noticing it because you're just turning it on. You don't think about those things that are there. And so if you've got live traffic that's running in your network, which happens a lot of the time when we're adding new security features, you've probably already got a production network up and running. And so thinking through the order of operations is a key aspect of kind of doing any kind of engineering and operations in a live network. Because oftentimes you can't avoid impacting your users, but it takes a little bit of forethought.
Notice I'm being a little lazy. I'm using the tab key a little bit. So first command I put in was switch port security MAC address. I told you that I wanted to do a static MAC address, and so I've punched in the MAC address of that first PC1. I've turned on the protect violation type, and now I'm actually going to turn on port security. Right? It wasn't on until I did this command right here. So let's have a quick peek. Show port security interface gig 0/1. It's enabled, secure up, it's set for protect, maximum MAC address is 1, total is 1, configured is 1. It hasn't learned anything yet, but that's okay. So I can do a quick ping off of that PC so that it would learn that information. Oops, there we go, where's my ping? There it is. And if I go back here, there you go, so there's my MAC address. Now, all we've done is the first half of that configuration task that the exam blueprint was asking us. It was, did you guys remember that sentence at the beginning, 5.7? It said configure and verify. So we've configured, we've verified, but what I like to do when I'm teaching stuff like this is break it and see what happens. I think that's my favorite. So one of the cool things you can do with CML is you can change the MAC address of devices. So I'll show you how to do that. I'm going to stop this device, and we're going to do that for all three. I'm going to wipe it. Then I'm going to go to interface, and you can see I can actually edit the MAC address. I'm going to do that. So I'm going to change the last values to 00. I'm going to check that, and I like to click this refresh button just for fun. There we go. And I'm going to restart the PC. All right. It's going to boot up pretty quickly, but let's have a quick chat here. So what should happen? The PC is going to boot up. As it boots up, it's set for DHCP. So as it boots up, what's the first thing it's going to want? An IP address. And this is DHCP. We talked about DHCP services.
We did DHCP in season 2 of CCNA prep. And so the DHCP process is going to come up, and the machine is going to send out a broadcast and say, hey, I need an IP address. Please, please, please give me an IP address. And that comes out as a frame that is going to be sent to our switch.
Yeah.
Our switch that has had some configuration on it. So what do we anticipate? Do we think that this machine is going to successfully reach the DHCP server? Anybody? Seeing some head shake? No, right? If you're on the web and you're in the chat, by all means, tell us in the chat. I am monitoring it in there. But I like that. You're thinking ahead, right? Patrick has already configured port security with a MAC address, and we've changed it. And so to speak.
I've got no IP address on this PC now. But I guess the point, remember the point I said, I wanted to show you how quiet things were going to be on the switch. This is how quiet it is. We got nothing here. No indication that something's happened. And look, I'll even pull up the port security output again. Did it increment the counter? No. Is the port down? No. The only hint that something has happened, the MAC address is changed here. It's noticed that the MAC address has changed, right? It was 11 before, now it's 00. So it has seen a new MAC address because obviously the DHCP sent a message in, but it was quietly dropped. And so there we go. Yeah. So no demonstration that it's actually doing what it's supposed to be doing, quietly dropping the offending traffic.
Now let's think through the practicality of this. It's like, how often is somebody going to go in and change a MAC address on a machine?
Yeah.
No, it's not going to happen.
Well, the hacker could.
However, well, a hacker could. I'm not even going to go there, right? Think about you're a network engineer at a help desk, and you get a ticket that comes in and from somebody and says, hey, I came in this morning and now I can't work, right? I turn my computer on and I can't function. And you see this as it goes through. As the network engineer, you may not know that the night before, right, they recently rolled out a PC refresh, and they came through and they took that person's desktop machine off and they've replaced it with a new one, which would change the MAC address. The user may not even recognize that because their monitor, their keyboard, their mouse, all of that may look exactly the same. They have no idea that IT came through the night before and swapped it out. And this is why this kind of combination of settings for me is really just a bad case. It's only going to generate trouble for network engineers and users. In my entire career, I've never seen a good use case for this capability, but it's available. So we do need to understand it as well as kind of have these discussions to see why it's not a good choice. And we have better choices.
So here's a classic CCNA exam question. Which violation mode would quietly drop the frame, not do this, not do, you know what the answer is. While Hank was talking, I reset the MAC address to PC1 to the right MAC address value. I restarted the PC. You can see a little check mark there is up and running. Again, nothing interesting has happened here on the switch, but if I go to the PC and I log in, so Cisco, and I do, I don't know, if config ethernet 0, see, I have an IP address now. I'm happy with that. That means I should be able to ping the internet. There we go. That's working beautifully. Again, though, if I go back to the switch and I pull up that show port security output, nothing really has changed here, although it has refreshed to the correct MAC address. So not the most exciting combination, but it's good to know how that one works. Any questions so far on that first one in the chat? We're good?
No, we've had some, but I'm keeping up with them.
Okay, cool. All right, ready for the second one. The second one, as you can see by the diagram, let me move it up a little bit. I want to set up restrict and dynamic. So that one is going to be pretty easy. Dynamic means it should just pick up the MAC address that's in the MAC table we were talking about earlier. So I don't have to do too much here, but I'm going to enable a couple of optional parameters that are available when we use dynamic secure MAC addresses. And I'll show you what I'm talking about here. So in gig 0/2, no, yes, 2, that's right. I'm going to do switch port security violation, and I'm going to go with restrict, right? Because that's what I want. I'm not going to set a MAC address because it's dynamic. It's going to pick it up from the MAC address table. But a couple of things we can do with dynamic is something called the aging time and the aging type. So by default, it will, once it picks up a MAC address, it will remember that MAC address for a certain amount of time, and that amount of time will depend if it's an absolute amount of time or inactivity. In other words, if the PC keeps pinging and sending traffic and connecting to the network, it keeps resetting that inactivity timer and keeps that MAC address in place. So I'll just show you what those parameters are, and I'm going to adjust them a little bit just to make things a little bit more interesting when we do the show output after. So switch port, port security, violation, no, my bad. We'll do aging, and we'll do time. Let me just show you what the options are. So it's in minutes, between a minute and a lot of minutes. I'm going to set it, let's say, to 30, just for fun. And then switch port security aging type. This is where things get interesting. So I'll just bring it up maybe a little bit so you can see. Absolute or inactivity. So by default, it was absolute, if I remember correctly. So I'm going to switch that one to inactivity, just to show you, again, some different things. So I've done a bunch of parameters, but I haven't actually turned on port security yet, right? So now I need to actually turn it on. So now it's actually on the port. So let's pull that one up here. So show gig 2. Let me just expand this a little bit so we can see what's going on. There we go. It's enabled. The port is up, set for restrict, 30 minutes of inactivity. So when it's going to, notice it hasn't picked up the MAC address yet. So let me just do a quick ping from PC2. There we go. And we'll go back to the switch. Fantastic. So PC2 has been picked up, right? That's a MAC address. We've got one maximum MAC address, total of 1. It's not a configured MAC address. It's not a sticky MAC address. It's just a plain old regular dynamic MAC address. Yep. That makes sense? And so and for the timing, right, for the age of the MAC address, 30 minutes of inactivity. So if that device gets disconnected, that would be very inactive.
It would be super
And
inactive.
after 30 minutes, it would flush the MAC address out at that point and pick up whichever the next one is that connects.
And use cases for something like this would be a room where you only want to have maybe one machine connected. That's all it's supposed to be used for. But it changes occasionally, right? So maybe it's a conference room or a shared space or a booth environment like this where people are going to be coming in and out. And you don't want to be tracking them and changing them all the time. They're going to adjust, but you still want to make sure that nobody's coming through. Or actually, they do that here at Cisco Live. Yes. They don't want vendors coming in and plugging in another switch into a switch port that's there and sticking things together. And so this is a way to kind of make sure that your network stays sized appropriately. There's a lot of different use cases for dynamic. And then like 1, 2, or 3, like you can set maximum addresses. Yeah.
While Hank was having a chat with you, you maybe saw what I did. I changed the MAC address of PC2 and I restarted it. And as we were chatting, look what happened. Syslog layer level 2 message, right? This is a critical message. Security violation occurred caused by MAC address, and you can see the MAC address ends with 00. That's the violating MAC address that I just configured on the port. And so remember we talked about how this mode is a little bit more chatty, right? It's not quietly dropping the traffic now. Now, why is it spamming me so many? Yeah. Any ideas why what's triggering all of these messages keep appearing? What's that PC trying to do?
Shout.
Trying to get an IP address through DHCP, right? Remember DHCP, DORA, it's a discover. This is showing me that the PC is sending a discover message broadcast. And again, and again, it's trying to get an IP address. Let's have a look at some show port security output here. So we can see that port 2 was set for 1, set for restrict, and this is the violation counter. If I scroll up again and I pull it up, it's now at 24. This is going to keep going. It's going to keep spamming us constantly because the PC is unhappy. It wants an IP address. It wants to get into the network. Let me make it stop doing that. No, hang on. Let's pull up the show port security interface gig 0/2. Let me expand this out a little bit. It's still up. The port is still up. That's the violating MAC address. And now we're up to, well, it was 25. It's probably going to be something more at this point.
Mm-hmm. Works out pretty well on that side.
Yeah.
So this is an area where, think back to that use case I had before. IT came through, swapped out somebody's, refreshed their machine. You come in, you get that help desk ticket. It will be very obvious that something odd is going on because you'll see those messages either on the console or hopefully more likely in your centralized logging systems. You'll see these things popping up. Maybe in the future, some AI will have already kind of raised a ticket to say, hey, port security is flagging on this machine.
So while Hank was talking to you, I just reset the MAC address on PC2. It's rebooting right now. These messages should stop. But more importantly, once that PC is done rebooting, it should have access to the network, right? It should be able to pick up an IP address. I do a if config Ethernet 0.
One of these days, I'm going to convince you to use the IP command.
I know. I'll try. I need to post it.
Yeah.
For Hank, use the better command, and then I should be able to ping also, right? So far so good. Those are just a couple of combinations of different static secure MAC addresses and port security violations.
Yeah. I like restrict as an option here for most of the ports because this is a case where if the problem gets fixed, right, somebody swaps a PC, they plug into the wrong port, right, it doesn't necessarily require the network engineering team to go in and re-enable the port. Now, if it's a high security location, right, maybe you do want to touch on it, but in a lot of locations, like this is really convenient.
One more to go. Port PC3. I want to go with shutdown and sticky. And we already know something about shutdown. I mean, we know a lot of things about shutdown, but one of the things we discovered earlier is that shutdown is the default value. So when I do the config, I won't have to, I mean, I could type it in again if I'm really concerned, but I know that by default it is shutdown. But I want to use sticky in this case. And so it's going to pick up the MAC address from the CAM table, the MAC address table, and then put it in what we did say. It's going to put it in where? In the running config, and then if I really want to keep it in place, I would do copy run start or write mem and then save that to the NVRAM. So this one's going to be pretty straightforward. So switch port, port security, MAC address, and that's where I'm going to use that sticky. All right, I don't need to do anything about the violation counter or the violation type, if you like, and then I'm just going to turn it on. And let me just send a quick ping, because I notice I keep forgetting to do that, and so we don't have a MAC address. There we go. So now it should have. Let's pull up some show port security commands. So I was waiting to do this one because I want to show all of them to you. So that was the first one that we did. This was the second one where we had loads of violations, and this is the one that we just did together right now. And if I pull up the output for gig 03, let me expand my window a little bit so it's easier for you to see. There we go. We're enabled. It's up, set for shutdown. It will never age out, right? The aging time is set to 0. I've got a maximum of 1, a total of 1, and currently a sticky of 1. So I'm looking good. That's the correct MAC address. You know what I'm about to do. Let's turn off this PC, stop, and wipe, and then click it, and then go down here, change the MAC address. So easy. Love CML. Refresh that. Let's restart the PC. And let's keep an eye on the CLI, right? As the PC boots up, I think we're getting an idea of what's supposed to happen, right? The PC is going to boot up. Okay, this is a little bit more dramatic than earlier. We still have our what did I say earlier? Critical syslog message, level 2. Indicating a violation has occurred, what the MAC address is. But look at all the other ones here. I think level 4 is warning. Warning for level 4. Port security violation, error detected on gig 3, putting gig 3 into error disabled state. And this is another classic CCNA question here for the exam, right? What happens to the port when the shutdown violation occurs? I know it's called shutdown. Is it actually shutting it down, folks?
Do you think that would be an option in the CCNA question? Option A, or the question, what happens when the shutdown state happens? Option A, well, the port is shut down. It seems so obvious. This is why knowing our material and understanding the details is so critical, because sometimes the obvious things aren't actually the right answer.
Let me pull up a bit of output here so we can have a chat about this. So this was a port, one violation, and it stopped right there. Why did it stop right there? Because the port right now is shut down. I know it's not shut down, but that's what we use as the violation. And if I pull up the output for gig 3, it's enabled. Oh, here we go. This is new. Secure shutdown. Fair enough. Violating MAC address. Our counter's gone up to 1. I just want to show you something else as well. Show interface status. Look at this. Gig 3. It's not connected. It's not connected. It's actually error disabled. So this is interesting. And this is another classic exam question that you're going to get. What happens when? What happens when a port is error disabled by port security and you want to re-enable it? Any thoughts? Has anyone ever played with this before?
We got a no shut as an option, a question.
That's it. Is it just no shut? Just type no shut? So the classic easy one is you actually have to do shut and then no shut. And that will bring the port back up. But if I do that right now, it's going to go down again because my MAC address is incorrect. So I'll change the MAC address in just a second. But what I wanted to point out, though, is that there's another way to allow the switch to automatically re-enable ports. And this could be a little sketchy because, I mean, if you've killed the port, maybe you don't want it to turn back on after a little while. But you can actually, and I go through this in the lab guide, so please feel free to have a look at that. There's a command, a global configuration command that you can put in place to tell the switch, hey, if ever a port is error disabled, turn it back on in 30 seconds, 30 minutes, an hour. In other words, and I can see the use of that to a certain extent. If someone does something dodgy, they won't be able to do anything, and maybe they'll get annoyed and frustrated and go away. And so the port comes back by itself after a little while. I don't know. Have you used the error disable aging?
No, I've never used it. And I think that there's another area where it could be convenient in a few cases, but it's one of those settings that if you forget it's there, just imagine the help desk tickets. The network was broken. I came back 5 minutes later. It was better. And then it broke again, and I came back 5 minutes later, and it was better. Like, chasing these things down could be really challenging.
So I fixed the MAC address, and hopefully you're going to realize what we've been talking about. Even by changing the MAC address, the port won't come up by itself at this point. It is in secure shutdown. It's in error disabled. And even though I changed the MAC address and the PC's rebooting, and it should reconnect in just a second and start trying to get an IP address, it won't. It won't be able to get an IP address at that point. And so, as we said, I'll go with the...
Yeah, before you jump into that, we had a question here, and I couldn't remember. So Ian from the chat asked, can you change, does Packet Tracer allow you to change MAC addresses like CML does? And I couldn't remember. Can you in Packet Tracer go onto a node, like, don't jump into it now.
Yeah, I'll open Packet Tracer and check. I think so. I think if you have the laptop or the PC device in Packet Tracer, and you go to the config tab, the config tab, I think there's a spot where you can do that.
Yeah, there's a lot of flexibility in Packet Tracer.
But that's it. The advantage with Packet Tracer is you can just disconnect that one, grab another PC, and connect it in very quickly, and do a test with that one instead. So I think that'd be fine. So notice I don't have any messages telling me that the ports come up. The PC is probably struggling desperately to get an IP address. Let's go have a look. If config Ethernet 0, right? No IP address on PC3, so it's very unhappy. I'll go back to the switch int gig 0/3. And this is what you guys said. I need to do a shut and a no shut. And once this is back up again, hopefully within a few seconds, the PC should pick up an IP address. We can go back just before we do that and do a quick show port security. So nothing much has changed here. We still have the one violation that occurred in the past, and we have our one MAC address. I can pull up the gig 03 output. And again, nothing much has happened here, but now it's at least secure up, which is good. It's expecting the 33 address, which I reconfigured on the PC. So hopefully I gave it enough time for it to pick up, oh, not PC1, PC3, to pick up an IP address. And it did. It's now got an IP address.
And I like the fact that the switch, the counters may remember that there was that violation, right? There are ways to clear the counters on the switch, but knowing that those are still there can be helpful as during security audits, operations pieces. Obviously, they'll get cleared if the switches reboot, but as you're doing your audits, and that's something you can monitor in your network operations system, like look for those counter values to see if there's a problem, because you generally don't want your security violations to go up at all.
No, you want it to be quiet. Yeah. Quiet on the network.
Yeah.
That's it for port security. So that's part one of the lab. I've got a completely detailed lab guide that goes through all of those steps, adding a little bonus extra information here and there to kind of explain why I'm doing certain things. And so that's part one. Part two is DHCP snooping. Yep. It's very easy to turn on, very straightforward. What's the point, Hank? I'm going to put you on the spot this time. He does this to me every time. He puts me on. I'm going to put him on the spot. What's the point, I guess? Because everyone, you know, we're being asked in the CCNA exam to configure this service, the security service or feature. Why?
DHCP snooping, I think it's all in the name, right? As network engineers, we are inherently mischievous, right? We want to understand what's going on our network. So we just like to keep an eye on things and kind of just peek under the hood, keep track of every single IP address that's issued to every single MAC address, because we're just that nosy. I mean, that's the reason, right?
And are we trying to protect ourselves against something with DHCP snooping?
Yeah,
I'm giving him I'm leading him to the water.
There's another good reason we have that. In a network, right, DHCP is a critical service. Most of our client-based networks require DHCP in order to issue IP addresses to machines. Every one of our laptops, both Patrick and mine, your mobile devices, if you've got a tablet device, here at the event have been using DHCP to get an approved, accurate IP address, as well as gateway, DNS settings, maybe a few other things. And so what happens if somebody comes in here, we'll say on accident, right? Maybe you're here on the show floor, you want to have your own wireless in your booth. You don't want to use the Cisco Live wireless, so you have rocked up to the closest electronics store, you bought a little home router and plug it in your booth, and every home router in the world comes with a DHCP server built in, and it just starts spewing DHCP requests. Immediately, everybody on the show floor may stop working, or maybe not everybody, but part of them stop working because your DHCP server issues an IP address that's probably 192.168.0.101 to all of your neighboring booth members, right? DHCP snooping is a feature that allows us to prevent that from happening, because you can indicate these are where I can expect approved DHCP settings to come from. And that's the real feature for it, is we want to make sure that DHCP is such a critical service that it will operate successfully. And if you don't turn on DHCP snooping, at some point that type of thing will happen to you, right? It's happened in several of the companies I've worked at or customers that I've supported at Cisco, is that someone will come into a conference room and plug in a wireless router. That's usually what it is. They plug in a wireless router because the admin assistant was told that there's a dead spot over there and just go fix it. Oh, I can fix it. I do this at home all the time. I'll just plug a router in. Right? That's the reason we have these features that are out there, is to prevent and maintain stability in our network, well, in layer 2 of the network.
100%. And while Hank was talking about that, I'm just reminding you what the current setup is. So the DHCP server right now is kind of hiding in here. It's invisible. It's on the CML server itself. And so what I did is I used this quite interesting command, sudo u DHCPC-r for release, renew, -i for the interface. And I did that on the 3 PCs just to show you that right now, if I release and renew, I pick up an IP address. I pick up the same one, but I'm just showing you that the 3 PCs can actually reach the DHCP server right now and get their IP address. And you can see I was pinging earlier, right, to 8888. So we know we've got connectivity throughout the network. Now, what I want to do is I want to deploy DHCP snooping in a strategic way. And usually the approach that you want to take is to set up DHCP snooping to kind of put on a wall of protection at the access layer, right? So that if someone accidentally connects a little router, a DHCP server, or a hacker tries to flood and attack your DHCP service, they usually do that at the access layer, right? They found a port somewhere, they've plugged themselves in, and they're trying to access your network. So I'm going to want to put up a bit of a wall of protection. I want to not trust these ports that are pointing down to my PCs, or in this case, that way, are going to be untrusted. Everything else I want to trust, right? If my server is here on the far left, the DHCP, the legitimate DHCP messages are going to be coming this way, right? The discover is going that way, and the offer is coming back. And so I want to trust the messages that are coming back in this direction. And that's what I'm going to do on the access switch.
Mm-hmm.
And then I'm actually also going to deploy DHCP snooping on the distribution switch. The reason I'm going to do that is I want to just show you there's a little gotcha maybe when you do that, and how to get around that little gotcha. So let's have a look at that. We're going to see that it's really easy to turn on DHCP snooping. So bizarrely, or I don't know why exactly, but anyways, there's two commands to get the whole thing going. There's a general DHCP snooping command, so there it is. So IP DHCP snooping, that turns on the functionality, but you can't just stop there. You actually need to then specify what VLAN you want to be snooping for. And we only have the one VLAN, it's VLAN 10. Now, what else do I need to do here? I'm going to show you a couple of extra commands. Interface range, let's say gig 0/1 to 3. Now we know what those ports are. Those are the ports on the far right of my switch. And what I can do here is IP DHCP snooping. I want to show you a couple of things. I can limit, oh, I need to spell that properly. I can limit the number of packets per second that I'm allowing in. Now, why would I do that? Like I was just saying a few seconds ago, if a hacker is trying to attack your DHCP services, what they might want to do is do a DHCP starvation attack. I don't know if you guys have ever heard of that, where you just kind of start sending lots and lots of DHCP messages into the network, or you're trying to redirect messages to your own server to kind of pick up, do a man-in-the-middle attack as well. There's a bunch of things that someone can do on purpose, or maybe not on purpose. So maybe I'm gonna minimize or limit the number of packets per second that DHCP is sending in. If I don't, the value by default is unlimited. So it's off it goes, right? So it will accept as many packets as you want. And then the last one, I was talking about trusted and untrusted ports. By default, all the ports when we turn on DHCP snooping is
untrusted.
Untrusted. I'm trying to put them on the spot again. Yeah, untrusted.
Right.
And so which one do I need to trust? I just talked about this a few seconds ago. Which port should I trust? Yeah, exactly. So int gig 00, IPGP snooping, and I'm going to trust this port. That's it. This one was optional. I didn't have to do that, by the way. Okay, but this one I definitely need it because the messages are going to be coming back. I need to trust that.
And I was answering a question I might have missed.
Sure.
It. Did you explain the key of the rate limiting on DHCP snooping? What might happen if you don't have that and someone is either maliciously or problematic? Did you go through that?
So a hacker could start sending thousands and thousands of discover messages to your legitimate server requesting an IP. Now, how big is your DHCP scope? Maybe it's this big, and then this attacker is going to just starve it. It's going to keep asking for an address and another address and another one. And then what happens if your pool is out of addresses and you're a legitimate user? You get to work one morning, you turn on your phone and you try to get an IP address and you can't get an IP address. So that's a classic one.
And you might be saying, you might consider that the attacker successfully denied services to the legitimate users. And so that would be considered a denial of service attack by flooding your DHCP server and grabbing all those addresses.
And then the other one I quickly mentioned, and we're not going to maybe get into it too much today, but a man-in-the-middle attack, right? Where a hacker will spin up a DHCP server connected to the access ports where all you guys are working. And because he or she are physically closer to where you are, when you send your discover message, they might respond first. It's like a race, right? Who's going to send the offer first, the hacker or the real server that's in the data center? And so you can kind of see what the man-in-the-middle attack could do. They will redirect traffic to themselves. We'll get Kyle here to talk about security.
Yeah. And if you're wondering how do they redirect traffic, well, they provide generally a completely valid DHCP request or response, but they say, don't go to the default gateway, send your traffic to me. And so then they route all your traffic through themselves and they can do all sorts of stuff with that.
So while we were talking, I refreshed the IP addresses on the 3 PCs because I want them to be snooped. I want to start building what we call the snooping binding table. So while we were talking, I just did a quick refresh of DHCP on the 3 PCs. And now I've pulled up this very useful command, show IP DHCP snooping on the switch. And it's confirming pretty much what we know. We know we've turned it on. We know we've turned it on for VLAN 10. And we know that we rate limited some of the interfaces to 10 packets per second. We know that we're trusting our uplink to the rest of the network, right? Trusted, there it is. So we know that it should be working. And because I did a quick refresh and renew of the IP addresses, perfect, I love it. So there we go. Because I released and renewed, the switch saw that traffic and snooped it, right? It sniffed that traffic and built out this information. So we've got our MAC addresses for our 3 PCs. What are their IPs? It looks like the CML server is configured to give out addresses for about an hour, right? But 33,600 seconds. We're snooping away VLAN 10. This is looking beautiful here. Does this look good for you guys? Yeah. So we definitely know that this is now going to carry or catch our traffic in terms of DHCP.
All right.
How are we doing for time?
I was gonna say quick time check.
Yes.
We got about 9 minutes left, so let's make sure we get through as much. We're probably gonna have to skip the last section, which is something we do occasionally because we like to talk. We like to talk about networking.
Yeah.
But the value is our lab guides that are built in here into CML as well as the packet tracer have all of the elements for this, so that you can grab those and dive into the dynamic ARP inspection on your own with your technology of choice, CML or packet tracer. But let's finish up the DHCP snooping thing. I think we've got enough time for that.
The last thing we were going to do is turn on dynamic ARP inspection, which again, it's like just a couple of commands. It's all detailed in the lab guide, so feel free to take a look at that. But notice I had this hidden for the whole session so far. I've got a little rogue DHCP server connected here. And so at the end of the lab, in the lab guide, what I get you to do is just turn it on, because I just want to show you what the switch does with that when it sees those messages coming in. So I might do that in a second, but let's try that. Let's see what happens, because I did it with DAI enabled, so we'll see if I get any interesting messages here. Debug, maybe what can I do here? I'm just thinking, what's that debug command? Yeah, debug. Oh, never mind. I don't even need to turn on. There we go. Yeah. Love it. So DHCP snooping is responding to me. It's saying that it received a DHCP message on an untrusted port, and look at that. Drop the message. Very, very quickly.
I like over here too, the message type is listed out. So Patrick mentioned Dora before, right? So we've got the DHCP offer, right?
There it is.
There's that O message coming. Oh, now we moved it. The offer message is the one that's going to go through, because an untrusted port would allow a discover message to come in because those are valid. They come from clients. It's the offers. It's the message types that come from servers are the ones that are going to be blocked on the untrusted ports.
And if I pull up, I think it's this command here. Yeah. Show IP DHCP snooping statistics. I can see that it's now dropping. So basically, I've configured a little server in CML to just spam, just like send DHCP messages into the network, just a trigger, just to make something happen. And so it's basically saying, yeah, I'm dropping these because I'm getting them on this untrusted port. And I can also see that in the show IP DHCP snooping command itself. If I do that one. Oh no, it's with DAI. It's when you have dynamic ARP inspection that you'll see the counters increase there. They go through.
Can you scroll back up to the statistics message?
Yeah, there we go.
Yeah, so we've got packets dropped and packets dropped from untrusted ports. It's an interesting one. Why are there two different ones? What type of packets might be dropped that were from trusted ports? Why are there two different ones?
That's a good question. Trying to think. I don't know if they'd be malformed. Maybe there's something wrong. That's a good question. Yeah.
I thought it might be rate limited, but those would have been from untrusted ports too.
Yeah.
So that was an interesting one. All right. I didn't know if you dug into that as you were digging through.
Yeah. Interesting. And then the other little bit that we're kind of running out on here, or do I have enough time to turn it on the distribution switch? Yeah, I just want to demo this as well. So far, we've just turned on DHCP snooping on the access switch, but there is another one in the way. So I could turn it on there too if I wanted to. So let me just show you what that looks like, and then show you what the gotcha is, when it comes to that. So I can do IP DHCP snooping. We know that we have to turn it on kind of globally, and then I'm going to turn it on for VLAN 10. That's good. Do I need to do anything else on this distribution switch, or am I done? By default, all the ports are untrusted. So which port should I trust here? The port going, you always want to trust the port kind of heading towards the DHCP server, right? IP DHCP snooping trust. So if all goes well, this should all work. And what I mean by that is if I go back to the PC, let me just maybe turn this thing off here so that it doesn't keep spamming the network. I'll wipe that guy. I'm going to do a release renew on this PC. Do we think it's going to work? Who thinks it's going to work?
I do, because I wasn't paying attention.
Okay, who thinks it's not going to work? And then I guess the question is, why do you think it's not going to work? It's not going to work. How come? What did we break? Well, there's something a bit peculiar about DHCP snooping. When the access switch initially does that snoop of that discover message as it's coming in, it does something interesting. It actually applies information to the gateway address field, option 82. Option 82 in DHCP in DHCP is usually blank. But the switch, because it's configured for snooping, it thinks that there's a DHCP relay agent somewhere. And it's adding information in the option 82 field. And then when the switch over here gets that message, it's unhappy about that. It thinks it's a malformed message. There's a problem with this message. I'll show you what the message looks like. Here we go. DHCP snooping, non-zero gateway address. DHCP snooping drop message from non-internet value, option 82, untrusted. So a message arrived on this port, which was an untrusted port, and the DHCP message was modified. And because it was modified, it doesn't know that it was modified for a good reason. It just knows that this isn't quite right. There's something odd with this packet, and so it's dropped it. Yeah. So one way of sorting this out is by basically telling the switch to stop doing that. Because in our case, we don't have a relay agent. This is just layer 2. It's just layer 2 straight to the server. If I had a relay agent, well then, yes, I would want this feature. But in my case, I don't. So on both switches, I'm going to tell the switch to stop doing that. So IP DHCP snooping, information, right? Option. And what I'm going to do is I'm going to say no. No IP DHCP snooping information option. Stop putting in that extra option 82 information. Don't touch option 82 on that switch. And I'm going to do the same thing on this one too. And then no IP DHCP snooping information option. So now if I go back to the PC, let's see if it works. Yeah. Now it gets through.
There are other options. Sometimes you need option 82 on there. And so the reason this is being triggered on the distribution switch is because the distribution switch doesn't trust the port connected to the access switch.
Yeah.
In a real network, we could trust that port. And if you trust the port, then it wouldn't drop that out.
Exactly.
So that's the other option on this side to go as well.
And it makes sense to trust it, right? If that's a distribution switch, it should be in a cabinet. It should be secure. No one should be playing around with the interfaces. So for sure, you could trust the distribution switch ports on both sides, and that would sort out that problem.
Maybe not trust everyone, but if you know it's connected to an access switch and you've got the proper monitoring and the things in place, like that's typically what you would do. All right, I think we probably got to close this down.
We're good, yeah. So like I said, the lab guide has part 3 detailed, very simple, turns on DAI or dynamic ARP inspection. And I think the only thing you need to keep in mind, especially when you're studying for your CCNA, you'll get a question. It's going to say, what needs to be enabled first before you can turn on dynamic ARP inspection? It's a little gotcha. And the answer is DHCP snooping. You can't just turn on DAI by itself. It has to fundamentally work hand in hand with DHCP snooping. So that's why when we did this lab, I wanted to cover both of these. So you turn on snooping, and then you can turn on dynamic ARP inspection.
Yeah. And you might be wondering, why is it so important? Well, ARP is all about like MAC addresses to IP addresses. So in order to actually do inspection for that, the switch needs to know the ARP or the MAC address and the IP address. And it learns that by snooping the DHCP messages. Because like I said, network engineers like to be nosy.
Yes.
We like to keep our eye on things and know what's going on.
For sure.
And so that's why it's so critical to kind of combine those features together. So awesome. Well, Patrick,
any other cool questions in the chat?
I hit a bunch of them in there. We're in good shape.
Okay.
Patrick, great session on this.
Thanks.
We really dove in. And we always do this. We were actually talking about this morning. Oh, I don't think we need the full hour to talk about this. Every session we do, it's so interesting to dive in to the details of these just fundamental aspects of networking to understand them better. And that's why we do CCNA prep, is we do it because you're going to see questions on the exam and the context, understanding how these things fit in, why they work the way they do, seeing them when they break.
Yeah. It
really makes it easier to sit down and take that next step and pass the exam, become a network engineer that's out there. So if this was your first session, those of you here in Melbourne joining us live, by all means, if you search CCNA Prep on Google or go to the Cisco Learning Network, you can register. We'll be back next week where I'll be talking all about access control lists in part 1. Right? ACLs are such an interesting topic that we broke it up into 2. So we'll be diving into the basics and the fundamentals, and then we'll be back the week after to go into more of them. And then we'll end season 3 with a topic about
AAA, basically. Yeah. So again, it's all about security. So I thought we would have a look more closely at TACACS radius, how to configure that on a switch. And in particular, really excited that CML 2.9 has containers for TACACS and for radius. So what I want to do is build out a little lab where we can demonstrate what the commands look like when you configure that on a switch, for example, and do a bit of authentication, authorization, and accounting. I'll be honest, it's a little advanced for the CCNA. In the CCNA exam in the topics, it's more of a describe or explain or understand. planned for AAA, but we'll do a lab for it, just to give you a chance to understand it more clearly.
All right. Well, thank you all for joining us. We are at
Yes.
the last day of Cisco Live Melbourne, but there is still plenty of stuff to see. We've got more sessions here in the Cisco
Yep.
U Theater. I believe there's breakouts going on. The World of Solutions is still open and ready for you to learn from all of our
Yep.
partners and the other Cisco showcase of the latest technology that's out there. So thank you all. And
Yeah,
we'll talk
cheers.
to you next
Thanks
time.
for coming out this morning. Appreciate it.